Hey, it's Mr. Lum again, and today we're going to be looking at mixtures of strong acids and bases, and looking at what we can calculate from that. So, when you have a strong acid combining with a strong base, one of them may be in excess. One might have more than the other, and this will change the pH. So, we have a question here that says calculate the pH from mixing 50 milliliters of 0.150 molar NaOH with 50 milliliters of 0.200 molar HCl. Now, the first thing that we need to do is figure out which one is in excess. Is the HCl in excess, or is it the NaOH is in excess? Okay? So, anyways, so what we need to do is first we need to calculate the new concentration of OH. Okay? So the concentration of OH after it is combined, okay, is going to be 0.150 molar times 0.0500 liters, 50 milliliters, okay, and it is going to be in a 0.100 liters, okay, 50 milliliters plus 50 milliliters is 100 milliliters, or 0.100 liters, okay, and we find that the concentration of OH is 0.075 moles per liter. Okay, and that is of hydroxide. Okay, and here is, let's calculate H3O plus. Okay, in other words, it's going to come from this, which is, again, concentration 0.200 moles per liter. And we are going to multiply this against our liters. Okay, and this equals so this is the concentration of OH after we dilute it by combining it with HCl, and here's the concentration of H3O after we dilute it by adding it to the mixture of NaOH. Now, what we see is that there is more H3O than OH, and if we were to calculate the number of moles of OH that we used, okay, and compare it to the amount of moles of H3O, or in other words, the amount of moles of NaOH compared to the amount of moles of HCl, we'll see that the acid is in excess, because this is a 1-to-1 ratio equation. So if we were to look at it, it would be something like HCl plus NaOH, and it would make NaCl plus H2O. So if this was 1 mole and this was 1 mole, then it would be in stoichiometrically equivalent. However, our acid is in excess right here. Okay, so how much is our acid in excess by? Well, we know that it's in excess because H3O again is more than right here. And so how much is in excess by? Well, we can figure this out using this kind of equation, where we can figure out H3O plus, and I'm going to write XS as in like excess is equal to our H3O plus minus our OH minus. Okay, so here is our formula here of H3O plus and how much is in excess by our H3O plus at the start minus our OH minus at the start. And when it says start here, we mean like, well, kind of after it's diluted. So the amount that it's after in the beaker, because these two are going to react, and then the new concentration of H3O is not going to be 0.1, because a bunch of this is going to react with this, and it's going to neutralize and produce H2O and of course NaCl. But some of this is going to be left over, so we need to figure out how much is going to be left over. So in other words, H3O plus excess is going to be right here of 0.100 molarity. Now we can just minus this 0.075, okay, and we find that our concentration of H3O plus excess equals 0.025 moles per liter. Okay, and here's the amount of excess H3O plus that we have. Now the question doesn't ask for how much excess H3O plus we have. It says what is the pH at the end. Okay, so since all of that OH was neutralized and a whole bunch of the H3O plus was neutralized, all we're left with is extra H3O plus. So this is going to be left in our beaker, and the question is, what is the pH of that beaker going to be? So we can just take this number and put it into our pH formula. So in other words, pH equals the negative log of H3O plus. Okay, so we're going to take this and put it right here. Or in other words, pH equals the negative log of 0.0. Okay, and therefore I've already calculated this, and our pH equals, well, again, this is two significant figures, okay, and so our final answer is 1.60. Remember, this is two sig figs, okay? The 6 and the 0 are significant, and the 1 is not. Okay, so this is two sig figs, okay? And that is the pH of our final solution, is 1.6. Okay?